In Lesson 3.2, we will be discussing logarithmic functions. In Video 3.2.2, our learning target is for students to evaluate expressions involving logarithms. In this lesson, there will be two types of logarithmic functions we will discuss. One is considered a common logarithm, and the other is called a natural logarithm. Logarithms, which are true for both common logs and natural logs. Common log is spelled L-O-G. That's considered a common log or common logarithm. And ln is considered a natural logarithm. Now, these properties discussed on this slide are true of both common logs and natural logs. If b is greater than 0, so your base has to be greater than 0, and b cannot equal 1, x is a real number, then the following statements are true. Okay, if you have log base b of 1, then your result is 0. Now, if you think about that statement, log base b of 1 is equal to 0, what they're really saying exponentially is b to the 0 power is equal to 1, right? These two statements are equivalent. This is written in log form, and this is written in exponential form. Okay, so the second property they're discussing is log base b of b is equal to 1. We discussed that on the previous video, that log base b of b is equal to 1 anytime our base and the number we're taking the logarithm of are equal, then our output is 1. And the reason for that is that b to the first power, base b raised to the first power, is equal to just b. Okay? Anything to the first power gives you the same number back. Now, right here, they're talking about the inverse properties in the last two bullet points. Log base b of b to the x power is just equal to x. And the reason for that is basically you're saying b to the x is equal to, right here, we're saying b to the x base b raised to the x power is equal to b to the x. Okay, or we could say since our base and this number are the same, then all we're left with is the exponent, which is x, so that is why our output here is x. Anytime we see b and raised to the power of log base b of x, then we're just left with x. The reason for that is anytime your base of your exponential term and your exponent have the same base, right here, sorry, if your exponent has log base b and your base of your exponential term is also b, these cancel out and leave us with just x. This is only true if x is greater than 0. Okay, in example 2, we're going to apply properties of logarithms. So those properties that we looked at on the last slide, here we can use them to evaluate certain logarithms. Here we're dealing with a common log, log. Our common log has base 8 in this case. And we want to know log base 8 of 512 is equal to what? Right? Question mark there. So 8 to what power? Well, in that question mark, I'm going to put a variable, and I'll just name that variable x. 8 to what power is equal to 512? Now, if you think about 8 to the first power, that's 8. 8 squared is 64. 8 cubed is 64 times 8. So if I take 64 times 8, 8 times 4 is 32. Carry the 3. 8 times 6 is 48. Plus 3 is 51. So we're going to say x equals 3. In example 2, part B, we're asked to evaluate 22 raised to the logarithm base 22 of 15.2. In this example, we can apply the property that states if we have an exponential base that is the same as our logarithmic base and we are raising that base of 22 to the logarithm of base 22, we can say that these cancel out and we're just left with our input, which is 15.2. Okay, anytime our exponential term has the same base as our logarithm here, those cancel out because they're exponentials and logarithms are inverses of each other. Those would cancel out and just leave us with the input of 15.2. In example 2, guided practice, we're asked to evaluate 7 raised to the log base 7 of 4. You have 4 choices here, A, B, C, and D. Apply the properties of logarithmic functions that we've talked about in this video and submit your answer.